Alright, in this video we are going to look at what we call the congruent complements and congruent supplements theorem. This is all just a continuation of our focus on proving geometric relationships. And so we're really going to, of course, first identify what the congruent supplements, the congruent complements theorem are. And then we're going to go ahead and actually prove the congruent supplements theorem today and be able to kind of use what we know about this proof into other circumstances. So let's first and foremost identify what the congruent complements and the congruent supplements theorem are. The congruent supplements theorem and congruent complements theorem are both extremely similar to one another. Let's start off with our supplements theorem. What we're saying is that if two angles are supplementary, we'll use our example here, if angle 1 and angle 2 are supplementary, so remember that means they equal 180 degrees, then what happens is that if 3 and 2 are also supplements, the only way that this works is if 1 and 3 are the same angle. Let me say that one more time. If 1 and 2 are supplements, aka equal 180 degrees, if angles 2 and 3 are supplements, once again, equal 180 degrees, well, what didn't change in the scenario? Angle 2 was the same in the situation with 1 and 2 and in 2 and 3. So the only way that 1 and 2 can equal 180 and 2 and 3 can equal 180 is if 1 and 3 are the same angle. And that's the exact same condition with our congruent complements theorem. If 4 and 5 are complements, equaling 90 degrees, if 5 and 6 are complements, equaling 90 degrees, 5 is the same angle in both of the scenarios. So the only way that this actually works is if 4 and 6 are in fact the same angle. So let's take a look here at our congruent supplements theorem, and we're going to prove this one here from scratch. Now remember, this is the proof of the congruent supplements theorem. That means we cannot use the congruent supplements theorem in this proof. It's always so tempting to be like, well, I just learned this brand new theorem. 1 and 2 are supplementary, 3 and 2 are supplementary. That means 1 and 3 are congruent. I just learned that theorem. Remember, we can't use its own theorem in its own proof. So let's start here. We know, of course, that 1 and 2 are supplements and 3 and 2 are supplements of each other. So that is what is given to us in this situation. So again, if we're starting to notice a pattern of these videos and in my explanations is I ask you the question is, what does it physically mean for 1 and 2 to be supplementary and for 3 and 2 to be supplementary? That's what you need to be thinking to yourself, is what does it mean from the statement that I'm kind of trying to lead myself into? And I'm realizing that if 1 and 2 are supplements and 3 and 2 are supplements, that means when you add these two together, they equal 180 degrees. So use that to your advantage, that you know what supplementary angles are. And if you know what they are, that means that you know their definition of supplementary angles. Well, now take a look at what happens here. You have the measure of angle 1 and 2 equaling 180, but you also have the measure of angle 3 and 2 equaling 180. Well, if 1 and 2 equal 180 and 3 and 2 equal 180, that means 1 plus 2 and 3 plus 2 are the same angle values. So that means we can go ahead and say that 1 plus 2 equals 3 plus 2. And again, that is a prime example. If A equals B and B equals C, then A equals C. That's our transitive property. Once again, it's of equality because we have not seen any congruency symbols. What do you notice about what's on both sides of our equal sign here? 1 plus 2 and 3 plus 2. What's in common? Hopefully we realize there's a measure of angle 2 in both sides. Well, when you think about that, if there's the same value of something on both sides, if I technically get rid of it on both ends, did I change the truth value of the equation or of the expression? No, I didn't. If I do the same thing to two sides of the equal sign, I keep the truth value the same. So if I want to show that 1 and 3 are congruent, I first need to show that 1 and 3 are equal in measure. So if I just simply get rid of, and of course we know it's not just magically getting rid of it, but it's subtracting 2 on both sides, I then did not change the truth value, but now I know that 1 is equal to 3. The measure of 1 is equal to the measure of 3. And by the definition of equal angles, or congruent angles, that when they have equal measures, they are congruent in figure. They are congruent in figure. And so that is our proof of the congruent supplements theorem. And we have, of course, identified the congruent complements theorem as well, too. In the congruent complements theorem proof, it would be the same concept, except these would just be turned 90 degrees, and up here would end up just being complementary instead of supplementary.